Hi guys, welcome to another video, and today we're going to be looking at nuclear fission. In previous lessons we've seen that nuclear fission can provide the energy to generate electricity for our homes. But what's the reaction taking place inside of a nuclear power station? Well, first of all, let's define what nuclear fission actually means. Now, the word fission just means to split a nucleus. So during nuclear fission, we're splitting a nucleus. Now, massive amounts of energy are released when we split this nucleus. But not every nucleus can be split. There's two in particular. We have uranium-235, and we also have plutonium. And we call these fissionable elements that can be split. As you see on the diagram, I have the reactor core of a nuclear power station. And you can see that we have these control rods, fuel rods, water, and we have this concrete case, which I'll go into in a second. But the fuel rods, where I want to focus on, these fuel rods will be made of either uranium or plutonium. And let's see what happens at the fuel rod. Well, first of all, what's to notice is that we fire a slow-moving neutron If we fire a slow-moving neutron at a uranium-235 nuclei or a plutonium nuclei, it causes that atom to split in half. It causes the nucleus to split. And it forms two lighter fragments. Now, these fragments could be radioactive themselves, and we'll get onto the problems they cause later on. But what's important to notice is that when the nucleus splits in nuclear fission, 3 more neutrons are released. Now, those 3 neutrons can go on and collide with another uranium-235 nucleus or another plutonium nucleus. So what we have going on, in a sense, is something called a chain reaction, where one reaction triggers another. Well, let's look inside of the core of our nuclear power station. We've already discussed the fuel rods, but these control rods are made of the element boron. And what the control rods are there for is to absorb neutrons. If the rate of nuclear fission is getting out of control, we can lower these control rods, which will absorb more neutrons. If we absorb more neutrons, we're going to slow down the rate of nuclear fission. The whole reaction is also done in water. Now, water acts as a coolant, but it also acts as a moderator. And what I mean by the term moderator is that the water is able to make the neutrons travel slow enough for nuclear fission to occur. If the neutrons are moving too fast, they can't be absorbed by the uranium-235 nuclei. The whole reaction will take place in what we call a concrete shield. The reason we use concrete is so that the concrete can absorb any radiation released. The reactor core will also be made out of steel, as steel is strong enough to withstand the high temperatures and the pressures. The energy released from nuclear fission will turn the water into steam, and that steam can turn the turbine, which turns a generator. So we get our electricity. Okay guys, thanks for tuning in. Stay in touch for another video.